In this video, I'm going to go over a C program to take the integers in an array and split them across two arrays, one for the even integers and one for the odd integers. And I'll show you two techniques of doing this. One that's going to use fixed size even and odd arrays, but that's going to take up more memory than necessary. And another technique that's more complicated, but is only going to take up as much memory as required to store the integers in each array. So here I'll say int array is equal to, and we'll make a test array. And I'll throw 10 numbers in here. We'll just put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll make a variable here, array length, and I'll set it equal to 10. Just so we have a way of referencing the length of the array. So one way that I could solve this problem is I could make even and odd arrays of length 10, knowing that the maximum amount of integers in the even array and the maximum amount of integers in the odd array would be 10, because there's only 10 numbers in the original array. So if our even and odd arrays are of length 10, that's enough space for sure. So we'll say int even array, array length, and then odd array and array length. And we'll declare two arrays, even array and odd array, that are both the same length as the original array. So they've got enough to store every number possible if necessary. So next we'll actually count the odd numbers and we'll put them into the odd array. So I'll say here int odd count is equal to 0, and then we'll have a loop that looks at each element in the array, and if it's odd, we're going to put it into the odd array. So I'll say for int I is equal to 0, I is less than the array length, I plus plus. So increment I from 0 up until the array length by 1 each time. That's going to look at each element in this array one at a time. And if it's odd, we want to put it into the odd array. So we'll say if array at I modulus 2 is equal to 1, let's put it into the odd array. So this operation here, array I modulus 2, the modulus operator returns the remainder of a division operation. And we're saying if the remainder of array I, when it's divided by 2, is equal to 1, it's an odd number. And that's how odd numbers work. If you think about 3 or 5 or 7, if you do division by 2, there's one remainder. So if a number has one remainder after dividing it by 2, we say it's odd. And we're going to add it to the odd array. So we'll say odd array at odd count is equal to array at I. So add the current number we're looking at in the array to the odd array when it's odd. And this odd count is going to keep track of the number of odd numbers. So we'll say odd count plus plus. And that's going to give us the sort of real length of the data in the odd array. Because the odd array has array length, which is going to be 10. But there might only be 5 odd numbers. That's what there is in this case. And if that's the case, we want to know how much actual meaningful data is in that odd array. And odd count is going to give us that as well. So we'll do the exact same thing now for even numbers. So here I'll say int even count is equal to 0. And that'll make a pretty similar looking loop. So I'll say for int I is equal to 0, I is less than array length, I plus plus. So we're going to look at each index in the array again. And we're going to test the number to see if it's even this time. So we'll say if array at I modulus 2 is equal to 0, then we know it's even. So with even numbers, this is how they work. If we take the number and divide by 2, the remainder should be 0 in the case of an even number. So that's how we detect an even number. And if you think about 2, 4, 8, even numbers in general, when you divide them by 2, you know you're going to have a remainder of 0. So here we'll add that number to the even array. So we'll say even array at even count is equal to array at I. And then we'll increment the even count by 1. So now after running both of these loops, the even array will be populated with the even numbers, and the odd array will be populated with the odd numbers, and even count and odd count will let us know how many elements are in those arrays in terms of how many elements contain useful data. So let's actually loop through those arrays now up until the odd count and even count and output the numbers, just to see if we stored them in those arrays successfully. So we'll say here, for int I is equal to 0, I is less than the odd count, I plus plus, and we'll print out the values in the odd array. So we'll say printf odd array, %d is equal to %d, and we'll output I and the value in the odd array at I. And then we'll do the same thing with even here. We'll say printf, throw in a new line. We'll make a loop here that goes from 0 until the even count. And then we'll say I++, and we'll print out the contents of the even array. So even array %d is equal to %d/n, output I, output even array at I. And we'll save that. And this should now give us an output of both arrays. So if we save this here and we run it, then we should see that the odd numbers are in the odd array and the even numbers are in the even array. And we should only actually output 5 elements per array because odd count and even count should only be set to 5, given that we had 5 even numbers and 5 odd numbers in the original array. So if we look at what we get back here, we get odd array with the 5 numbers, and there's those 5 odd numbers, 1, 3, 5, 7, and 9, and same thing with even array. Even array contains the 5 even numbers. And so we've successfully now split the numbers in the original array based on whether they're even or odd into these 2 arrays. Now the only problem with this approach is you see that both arrays only store 5 numbers, yet both arrays have a length of 10. So this way of solving the problem is not going to scale very well. Imagine we have an array with hundreds of thousands of elements in it. At that point, there's going to be much wasted space potentially in the even and odd arrays. So what we want to do is find a more elegant solution to this problem. And what I'm going to do to solve the problem is I'm going to use dynamic memory allocation. And I'm actually going to create arrays that are just large enough to store the number of even numbers required and the number of odd numbers required. And for this solution, I'm actually going to put it in a function instead of actually just writing in the main function. So I'll make a function here called void split nums. And we're going to have a number of arguments here. So I'll say int array, and the first argument is going to be the array itself, and then int array length, and the next argument is going to be the length of that array. These arguments are both inputs to the function. The next arguments are going to be, in some sense, outputs, in that the function is going to use them to effectively return more than one thing. So here I'll say int star star odd and int star odd length. And both these arguments are using what are called pointers. We would say that these arguments here are a concept called pass by pointer. In the case of this argument here, it's actually a pointer to a pointer. So this is actually some pretty tricky stuff here. And there are some other videos out there explaining these things in more depth if you want to check them out. I'll leave those in the description as well. So this here is actually a memory address that we're going to be giving split nums. And it's going to be a memory address for an int value. That's what it means to be a pointer, is that you store a memory address. And by passing a memory address to split nums, we're going to be able to actually manipulate the variable with that memory address. So in main or whatever other function calls split nums, there's going to be variables for storing the number of odd numbers in the array. There's going to be a variable for storing the actual array itself. And what we're going to do is we're going to manipulate those variables in main or that other function using pointers by passing memory addresses for those variables into split nums. And this here is going to be the length of the odd array. This here is going to be the odd array itself. And what we really have are pointers to those things. That's what the stars are. We're going to have memory addresses to those things that allow us to access them. So here I'll say int star star even and int star even length. And we're going to have similar variables for the even array and the number of even numbers in the even array. So next we'll provide a definition for the function down here. And the first thing we're going to do is count the number of even numbers and odd numbers in the array. So that way we know exactly how much space to allocate for the odd array and for the even array. So here I'll say odd length is equal to 0 and even length is equal to 0. And you notice I'm putting this star in front of odd length and even length. That's the dereference operator, because odd length and even length are really going to be memory addresses for variables in main or some other function. And when I say star odd length and star even length, what I'm effectively doing is accessing that variable and manipulating it. So we're setting it to 0. And we're going to count the number of odd and even numbers using these. So here I'll say for int I is equal to 0, I is less than array length, I++. And what we're going to do is look at each element in the array using a loop pretty similar to these ones. So I'll say here, if array at I modulus 2 is equal to 1, then we know it's an odd number, and we'll increase odd length by 1. So we'll say star odd length is equal to star odd length plus 1. Otherwise, we know it must be an even number, and we'll say star even length is equal to star even length plus 1. And then odd length and even length, at least what they're pointing to, are going to contain the counts of the number of odd and even numbers in the array. And we can use these to go out and get just enough space to store exactly that many numbers. So here I'll say star odd is equal to malloc star odd length times size of int. So malloc is going to go out and get a block of memory for us, and it's going to return a memory address for that block of memory. Here we're requesting the number of bytes we need, and we're saying we need this many integers, because size of int returns the number of bytes required to store an int, and if we multiply that by the number of ints we need to store, that's how much space we need. Now malloc is going to return a memory address. This here star odd, we're again using the dereference operator, and we're going to set the odd pointer in main, or whatever the function is calling splitnums, to this memory address, because we're dereferencing here a pointer to a pointer. And when we do that, we're actually accessing a pointer value itself, this time in main or whatever other function is calling splitnums. So we're going to do a similar thing here for even. We'll say star even is equal to malloc star even length times size of int, and we'll create enough space to store however many even integers we need to store. So the next thing we're going to do is actually loop through the array one more time. And this time we're going to store the values we need to store into the odd and even arrays here. And we're going to have to dereference odd and even to get at those arrays. So here I'll say int array count is equal to 0, even count is equal to 0, and odd count is equal to 0. And we use those as our counters to actually increment and keep track of where we are in each array. So we'll say here, while array count is less than array length, we're going to keep going. And we'll say if the array at array count is odd, so if modulus 2 is equal to 1, if it's odd, we're going to store into the odd array that number. And this is going to look a little bit weird here. I'm going to say here star odd and then odd count is equal to array at array count. So remember, odd is a pointer to a pointer. It's a pointer to an array. So when I say here star odd, I'm dereferencing odd, and I'm going and getting the array that odd is pointing to. And then once I've done that, then I can use the array syntax to actually access that array. So again, this is a little bit weird to see this sort of dereference operator inside these brackets like this, and then we actually go and access it like it's an array. And again, this is related to a concept called pointers to pointers. And it just has to do with this here, this star star odd, the fact that we have a pointer to a pointer, and we really have a pointer to an array. So we have to dereference it before we can treat it like an array. So once we've done this, we'll increment odd count by 1. Else, if this is not the case, we're going to do a similar thing here with even. We'll say star even count is equal to array at array count, and we'll increment even count by 1. So we're just storing into the odd and even arrays here now the values from the array when they're odd or when they're even. And we're incrementing odd count and even count just so we can keep a running tally of how many odd and even numbers we've encountered. So that way we know where to store the next odd and next even number that we encounter in the array. We're also going to have to increment array count because we're using array count to keep track of how many elements we've looped through so far in the original array. So here we'll say array count plus plus. So when this is all done, we should have now sorted out the even numbers into the even array and the odd numbers into the odd array. So let's actually try calling this function now. Up here, we're going to have to make some variables here to actually do the returning that we were talking about via the pointers here. So here I'll say int star even is equal to null and star odd is equal to null. And these here are eventually going to store the actual arrays that are allocated by split nums. These are the pointers that are going to become pointers to pointers. Then I'll say int even length is equal to 0 and odd length is equal to 0. And these will store the actual lengths of the even and odd arrays themselves. So next we'll call the function. I'll say split nums and I'll give it array and array length as arguments, as well as and odd length and even length. So here, when we use the and operator in front of all these variables here, what we're actually passing in is the pointer. The and operator goes and gets the memory address of odd, the memory address of odd length, and so on. And so when we give the memory address of odd length, we're not giving 0. We're giving the memory address of this actual variable here. And that's how the split nums function is able to modify it, because it dereferences it and actually accesses odd length in main here and is actually able to change it. In the case of odd and even, these are actually themselves pointer variables. They're going to point to the array that we create in split nums. So when we pass in odd and we pass in and odd here, what's actually happening is we're passing in a memory address to a pointer, which itself stores a memory address. So that's why split nums has the star star odd and star star even, because we're giving a memory address, which is effectively a pointer, for something that actually is a pointer. So after we've called this function, let's actually see if we have the right values in even and odd length and even length. So here I'll say for int I is equal to 0, I is less than even length, I plus plus, and we'll say printf even %d is equal to %d. We'll output I and we'll output even at I. And we'll also output the odd array. So we'll say printf /n for int I is equal to 0, I is less than odd length, I plus plus, and we'll print out odd %d is equal to %d, and we'll output I and odd at I. And we'll save that. So we'll give this a run here. And we'll see if we get the odd and even numbers separated into these odd and even arrays here. So it looks like something might be wrong. Implicit declaration, oh, you know what I forgot? When you want to use malloc and calloc and free and functions related to working with memory, you have to include stdlib.h. So I forgot to include stdlib.h. So I'm going to go do that now, because that library is what actually contains malloc. So I'll include that, and then we'll give it another shot here. So I'll try to run it now. And we can see here that the even array contains the even numbers and the odd array contains the odd numbers. And it looks pretty similar to what we had before. But what's good about this now is that if we suddenly had, say, many odd numbers, we've got more efficient memory usage. So let's say this entire array here now was odd numbers. We'll replace every number here with 1. So they're all odd. In this case here, the even array is actually going to be blank. There's not going to be anything in the even array. In the odd array, there's going to be 10 values. So the odd array has 10 values, and we actually don't even print out the even array because even length is 0. It's just kind of nice because in the case of this even array and odd array up here, we made both of them array length in length. And so we're kind of inefficiently using memory because they're both storing the maximum number of possible values they may need to store. Whereas in this case here, we're kind of efficiently allocating exactly as much memory as we need to store the number of odd integers and the number of even integers. So this solution is more complex, but more efficient. I thought that was kind of cool, so I figured I'd show it to you. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.